the grade something else. Take that as a quiz. And I'm going to limit you to 2 questions with me. Because sometimes some of you get a bit on the needy side and you have to come up for every little thing. You don't even try the Tom before you ask me. So it should be 3. No. Write these down, please. Let's do these as examples. I'm going to find here negative x over 5. Uh-oh. Another little arrow sticks there. Negative x over 5 is less than 5. Let's throw down there. Maybe 18 is greater than 3r. Let's put on there maybe negative 4m is greater than or equal to 7. And one last one just to spice things up a little bit. I don't know. What's a good one there? How about 1/2 is greater than or equal to negative 4a? 1/2 is greater than or equal to negative 4a.
Are we graphing?
You do have to graph. Solve and graph. Solve and graph.
You so
Spam. Please refrain from all questions until after I've tried to solve this. Okay. Step number 1, children. You really have to just, first of all, you think of them just like equations. You solve them just like equations, except there's a few minor little things there. With inequalities, the x must end up on the left. The variable has to be on the left. I know I've talked about this before. Has to end up on the left. Okay, and then the third thing you have to remember is that anytime you change the variable signs, if you change the signs of the variable, change a variable sign by multiplication or division, by timesing or division, the inequality changes to its opposite too. Okay. Now notice I didn't say if you change the sign by adding or subtracting things, then it doesn't change. Okay. But if you change it by multiplication or division, it does change. So taking, for example here, problem number 1. If I'm solving that, I want to get the letter x by itself. What's the first thing I have to do? I get rid of this dividing by 5, so I'm going to multiply both sides by 5. I know you wanted to say that. That gets rid of this 5. You multiply by 5 over there. Now I have a negative x is less than 25. Okay, the x can't stay negative. You have to switch its sign. So this becomes positive, this becomes negative, this becomes its opposite. Just that easy. And then graphing it looks like this at negative 25. You have an open circle. Why is it open? Because it's not equal to it. It starts there, but it doesn't equal that. And this little arrow shoots off this way. Why? Because it's all numbers that are greater than negative 25. Now, Lucas, your question.
I don't have one more. Wait, oh yeah, I do. But why does it have to be on the left?
Because that's when we graph the arrows, that's the way we work it. Just go with it. How about this? Because I said so.
So like on 8.
Because that's the way mathematicians have done it for years. I don't know.
So
So this one here. Don't ask the question, Lucas, until I've gone through it already. Nick Shanks? This one? Variable has to be on the left.
Oh, number 3.
Number 3 says if you change the variable by multiplication or division, the inequality has to be changed to its opposite too. So this problem right here, I should go over the different ways that you can think about changing this. Okay? I'm going to write it right here. if you have 18 is greater than 3r, okay? Jackson. Well, not to that point here. Okay, you need to get the r over to this side. How are you going to get the r over to this side? Well, a couple different ways you can do it. You could subtract 3r to get it over here, so you end up with a negative 3r over here, and then subtract 18 to get it to the other side. So you end up with negative 3r is greater than negative 18. Now I didn't change the sign. Why? Even though the variable went from positive to negative, why didn't I change it there? Because it wasn't by multiplication or division. It was by addition and subtraction. I moved it over. The sign doesn't change. But now, when I do the division, now I am changing it by division, and the sign will change. Divide by negative 3, this becomes positive. This becomes its opposite. Divide this by negative 3, you end up with that. R is greater or less than 6. Okay. You also could have thought of this like this, and I think we talked about this before. I'm just going to throw it over here. 18 is what? Less than 3r? Is this what it was?
Greater than.
It was greater than? Okay. You can flip these things from one side to the other. In other words, you could put 3r over here and 18 over there as long as you flip the sign as well. The important thing to remember is that Mr. Alligator here, with his little sharp teeth, he always wants to eat the bigger thing. And the 18 is bigger than the 3r, so even though they flip-flop sides, the alligator still has to eat the bigger thing. Okay, and then you could just divide by 3, divide by 3, you're still going to get r is less than 6. Okay, you could do it that way. If that floats your boat any better, Lucas Manuel, feel free. Lauren Daffenberg.
Why does the letter have to be on the left side?
Wait, did somebody already ask that?
Lucas.
Just because. Because that's rule number 2.
That's like saying, can we not do homework just because?
Yeah.
Huh?
It's like saying,
Just
can we
no,
do
it
homework
isn't.
just because?
You don't have any authority to say that. When the dictator says that's the way math.
I'm going to Supreme Court with this.
Mostly because, Lauren, it's just the accepted way to do it, because if you say this, I mean, you could, I guess you could say, you have what, r is boom or boom. Because if I told you, if I said 6 is greater than r, how long does that take you to think about as compared to r is less than 6? When I say r is less than 6, automatically thinking, oh, the number's 5, 4, 3, 2, 1. If I say 6 is greater than r, oh, huh?
It doesn't take that long. Either way.
75 is greater than or equal to x. What numbers are that?
It's like 75.
What's that? Lucas Spaniel?
It's 75.
Probably because when you say this, you're talking about the variable. Okay, you're not talking about 75 being greater than or equal to x. You're talking about numbers x being less than or equal to 75. You're not talking about 75. 75 is not your focus on this axis. But again, I don't know. That's just the way math people do it. Go talk to Mr. Isaac Newton or whoever discovered that. I don't know. How about this? Do it or you get it wrong. That's a pretty simple thing. Wow. All right, solving this one then, Sage Hyde. What do I have to do?
Divide by -4.
And if I divide by a negative, that means
It's positive. And then James.
right. I need to divide by -4 because the m has to be positive. I divide this by -4, but then this sign is going to change, so it's going to be m is less than or equal to -7/4. And yes, believe it or not, children, you can have fractions, and it doesn't really make any difference when you graph it, because at -7/4, you're just going to put an closed circle because it can be equal to, and it's all the numbers that go less than. So it's going to go like that. And then the last one. The last one. First thing I would do what, Hanks?
Add the 4A to the other side.
Okay, if I add 4a to this side, it becomes positive, which is a good thing. And then I'm going to want to subtract 1/2 to the other side. So it's going to be -1/2. Sign doesn't change again because it wasn't by multiplication or division. Okay, and now, how do I solve this, Jack? Roll.
You turn the 4A to -4A and turn the 1 half
I
into.
don't believe I do. I think I wanna get the letter A by itself.
Oh yeah. You divide it by 4.
Divide by 4. And 1/2 divided by 4 is the same thing as -1/2 times 1/4. So A is going to be greater than or equal to
1/8.
-1/8. Random normal, sir.
For you're adding -4 to one side, I'm thinking,
Did you always do the opposite?
well, because it's in one of those things, right? That's causing out the -4.
Yeah, this is completely gone on this side, but it still is a positive 4A on this other side, because what you do to one side, you have to do to the other. So I added 4A to both sides.
Wait, did you change the sign? Did you change the sign?
Why would I change the sign, ma'am?
I don't know.
I don't just randomly change signs.
Because you divided, I don't know,
Did I divide by a negative?
I don't know.
One time you change this, you divide by negatives. Alright, now it's time for you. You solve this one for me. 27 is less than or equal to -9 plus, I'm sorry, let's go minus.
Wait, is it less than or greater than?
Greater than, I'm sorry. X over 4. Let's go X over 3. Just keep it simple. 27 is greater than or equal to -9 minus X over 3. I'll give you 3 seconds. 2, 1. Always graphic. Depends on the big as a relative term. I'm sure nothing bigger than 100. Huh?
Oh, I got the same thing.
No. Oh, maybe.
Yeah.
Yeah, a little over 100 maybe.
Maybe
Not much.
maybe like 9
I didn't get that.
Could be. I wouldn't be surprised if. Let's see, what Jackson Torok says what? Wait, anybody else on that one? Oh, yeah, we've got a half and half. Oh, Nick says X is greater than to a -108, anybody get that?
I did not
No.
get that.
Lauren says,
X is greater than or equal to -80.
Oh. Spaniel?
Yeah, X is less than or equal to -100.
There's a lot of.
Wait,
One
I got-
or
no,
108.
I got,
108.
I got less than.
Emma Haynes,
I got X is less than or less than or equal.
Yeah, I got -12.
-12.
Mr.
Yeah, I got that.
I take
Yeah.
mine back. I take Lucas's.
Alright, let's just stop there. Obviously, failure is.
It's
Alright. Two ways, a bunch of ways you could do this. This is the way I'm gonna do it. Well, I'm just gonna add 9 first. Add 9 to this, I get 36 is greater than or equal to the -x over 3. I'm gonna multiply both sides by 3, get rid of the 3, multiply by 3, I get 108 -x. I'm gonna add x to get it to this side, and then I'm gonna subtract 108 to get it to the other side.
Yes, I
And
did
then
it.
because
I had to sign
I
it.
don't change the sign because I'm not doing it
No,
by
you
multiplication or
I did
division.
it.
No,
They
that's,
did.
that's
They
I had to sign wrong.
So-
Actually, I did with my first name.
Who was this person?
Cheer.
Me. After I switched the sign.
How many people got that right?
I got
No,
one.
I have
Woo!
No, we're not doing order of operations here. No. In equations, when we do equations, you get rid. Really, the thing that when we solve equations, you actually work order of operations backwards because that's what you do when you solve an equation. If you remember back in 7th grade, they asked you to solve this without doing anything. They would just go 2x plus 3 equals 9. And they said to you, okay, if you're doing this mentally without doing all the things that we do, they would say, well, how would you figure that out? Well, the first thing you do is you would say, okay, what number, when you add 3 to it, gives you 9? 6, and then you'd go, okay, 2 times what number is 6? 3. So you know the answer is 3. But when you do that, you're actually going backwards from what your answer is, and you're doing this. What you're really doing when you say that is say, okay, 9 minus 3 is 6, and then 2 times what number is 6, that's where the 3 comes from. That's the same thing we're doing when we do this. Subtract 3, we always do that first. Get rid of that, 2x equals 6, so x equals 3. So when you do, order of operations is backwards when you think about solving equations. If I just had a string of things to do mathematically, yes, but in that case, no. So far, so good. Let's try another one. I should look at that page there. It's million divided by 2. Yes. No, I want something that at least you're capable of.
You have to make really big numbers, just make everything bigger.
Sure. Negative 2a is greater than or equal to negative 5.
Negative 2 what?
I'm sorry, negative 2a. Negative 2a is greater than or equal to negative 5. Rock and roll going on. Michelle's wonderful. Sayonara.